Hey everyone, welcome to Istio Weekly. Thanks everyone for joining. Today we have a special guest, Adam Zwicky from Tetrate. He's a global solutions engineering director. Adam has a broad and deep experience in enterprise software from architecture to delivery at SpringSource, Pivotal, VMware, and now Tetrate. We're super excited to get a chance to pick his brain about how Service Mesh meets the needs of the enterprise in the real world. We'll have dedicated time for QA after the presentation, so if you have any questions or comments, please do put them in the chat and we'll do our best to get them answered.
So before we catch up with Adam, though, we should mention our upcoming webinar. September 22nd, Tetrate will sponsor a panel of fintech leaders hosted by MIT Media Lab fellow Douglas Kim to discuss application security in a contactless world. With the unprecedented shift in payment technology from cash and card swipes to card taps and mobile apps. Oh my God, I can't believe I wrote that. Means for financial technology and applications. It's going to be a really interesting discussion, informal, between folks running things in fintech and Douglas about what this unprecedented shift, especially motivated by changes in patterns due to COVID-19. So we do hope you'll join us if you're at all interested. And we also finally want to make sure we hear from you. What else is happening in the service mesh world? What topics would you like us to cover here? Please leave your thoughts in the comments to the video and also at GitHub. And as always, the links for all the resources and more can be found in the description below. And with that, let's bring Adam in.
Hey Adam.
Take it away, Adam.
How you doing?
Hey guys.
How you doing?
Good. I'm doing great. Thanks for having me on here.
Awesome. So what are you going to talk to us about today?
So as the intro said, we're going to talk about why enterprises need just that, an enterprise service mesh. I would say the punchline is, where are the edges or the complexities that start to arise in large companies and production deployments for companies that are using Istio, using a service mesh.
Awesome. Well, all right. I'm not going to talk much more. I'll let you do it. So let's switch to your slides and take it away.
Good deal. So let me just jump in. So my plan here is to do a whole bunch of show and tell. So I do talk with a lot of customers. I'm in sales, so I'm definitely more than comfortable and happy talking with presentations. But I think for this audience, I want to show you some of the things we're going to talk about. Now, I have the fortunate position to be able to work with a lot of large organizations that are just beginning their cloud native journey or beginning their journey with Istio. And at Tetrate, we're really exposed to what I call some of the sharp edges or challenges that organizations start to hit as they adopt software-defined networking within their Kubernetes environment, introducing a service mesh, and more importantly, spanning that across multiple compute environments. And so, and that's what I'm going to address here. Kind of what are some of those challenges and how Tetrate solves those. So when we look at what are some of the major roadblocks, they really fall into two different buckets. First is more of the technical bucket of how do I do certain things and how do I make this span heterogeneous compute. And then the second bucket, as you could probably guess with just about any technology, is more about people, process, governance, and how does it affect their actual working day in and day out life. And so the biggest gaps on the technical side really revolve around what happens when you want to span across multiple environments, multiple clouds, multiple even clusters within a single cloud, multiple regions. It gets complex pretty quickly because there's lots of challenges that arise around how do I manage and shape my traffic across those compute environments? How do I have consistent chain of trust, and how do I do things like MTLS between all my services in these clusters? And not only just let me encrypt my traffic, but figure out how to author policy and take into account the cryptographic identity that gets encoded in all the identities of our services that run the mesh, and use that globally to establish trust. And then lastly, many organizations, as they go down this journey, find that they're going to have many, many clusters, many, many meshes. So simply keeping Istio up to date, keeping it current, and doing upgrades becomes quite a burden. Now, those are the environmental issues that most often come to the forefront. The second side of it is the people aspect. How do we enable the right people to do the right things to fulfill their responsibilities? And what I specifically mean about that is in the typical enterprise, those that are working in cloud environments and working with cloud native applications, you have those that are DevOps, those that are developers or responsible for application operations, those that are responsible for security and securing the services and setting baseline policy for security. We have individuals that might be a little bit more responsible for the platform and maybe higher level load balancing approaches. Each of these has each of these roles have a very specific duty that we want to enable them, and we want to then enable them to do that consistently across all the environments that they manage. Then we want to have visibility into what changed, who changed it, are we doing things the right way. For any organization that has begun adopting Istio, you've probably found that that starts to get somewhat challenging with all the nouns and custom resources that you deal with within service mesh. And then lastly, this really is all about applications, APIs, the things that organizations are producing. So being able to have an extensible framework and expose that using the nouns that most developers probably are most familiar with, which are going to be applications and APIs or services. They don't really want to care about the very, very low level details of service mesh and the Istio CRs, all that sort of stuff. And so at enterprise scale, those become the large challenges that need to get solved. And so that's why, in a large part, why Tetrate exists. And in many of those challenges that are articulated, you see this pattern that emerges of needing an overarching management plane that understands all your compute, all your clouds, even your legacy infrastructure, and can consistently apply policy, uh, consistently understand the topology so it can route into intelligently, provide multi-tenancy, provide RBAC access to give those personas, be it DevOps or security or whatnot, the right access to the right configurations to deliver that to their actual local clusters. And then lastly, this central thing can certainly manage the lifecycle of all the local Istio clusters, all the local control planes that exist within an environment. So this is really kind of a architecture view of what TSB is, Tetrate Service Bridge, which is Tetrate's enterprise product. I'm going to get you into actually showing how it solves some of those common challenges. So that's about the last kind of pitchy slide I'm going to do. What I'm going to demonstrate for you all is how do we actually look at a global mesh? And in my little demo environment, I have 5 different Kubernetes clusters. They're spread across 2 different cloud environments, a private data center and a public data center. We're going to tag them and kind of pretend that some clusters are secure and some are insecure. So this kind of looks like a simplified version of a typical enterprise, and we're going to call this a global mesh. So we're going to look at how can we slice and dice this and have various personas or various app owners get their little corner of the mesh that they can start to deploy and configure stuff. And then we're going to look at how does this automatically propagate things like routes and endpoints and security policy and load balancing endpoints so we can correctly shape traffic. I had planned to show you a little bit of VM onboarding, but the demo gods and the public cloud gods were against me today, and I had a couple challenges. So we'll put some videos and links in the notes of this show that will send you to some other recordings of that neat stuff. So let's talk about multi-tenancy and what we mean by that. So as I said earlier, we have a lot of different personas, a lot of different roles, and they're going to have specific logical groupings within your actual physical infrastructure, your physical compute that they deploy their applications. And so let's imagine that you have 3 different teams that build sets of applications. Maybe they're all part of the same business unit, but they're building a large application platform themselves. With the exception in this slide, Team 3 actually is building 2 big applications. And so as we look across our clusters and we look across what we describe as the global mesh, we want to start to slice and dice that to give team one access to the appropriate configuration and isolate them from the configuration and the roles and what the other teams are doing. And similarly with team two, three, and so on. And so the way we do that within Tetrate Service Bridge, within TSB, are using logical constructs of tenants, workspaces, and groups. A tenant is probably what you'd imagine. It's a logical construct that represents a large entity, which then has workspaces, which are going to be really just a playground at which they can start to access their individual compute and start to map configuration to that compute. Now, these concepts are really just logical that allow us to define who can do what and who can see what, to apply RBAC policy or access control policy for that. Now, within this hierarchy, the workspace is the most important construct because this is where we actually begin to map a logical construct to our actual physical compute infrastructure. And we do that using a tuple of clusters and namespaces. And you see a little YAML snippet on the right side that shows what that looks like. In our case here, we're defining a workspace. Its name is W1, and it's selecting any compute infrastructure within the global mesh. In our case, the wildcard means any cluster that has namespace 1 in it, or our C2 cluster that has namespace 2. So as we author policy, as we configure things like gateways or circuit breakers or any of the typical mesh configuration that we might do, that's automatically going to be pushed down to all those clusters. This also gives us a grouping that we can start to set default policy. And this is one really important and powerful construct I'll demonstrate for y'all. Imagine the scenario, what we see here in this last bullet. So you're a platform operator or maybe a security architect that's part of a platform ops team, and you want to set a default set of policies for all your gateways or for how your traffic is managed for this specific set of applications. And you don't want your app teams to have the ability to configure that. So at this workspace level, we have the ability to, one, set RBAC policy that says, let's pretend myself, Adam Zwicky, is a security architect. I can set policy that says, based on my role, I can author security policy, but my teams are identified by our identity systems as just developers. They're maybe only having read access to security policy. And then it allows me to author that default policy that trickles down to all the clusters, all the namespaces that are part of this workspace. And so I'll demonstrate that for us. So let's jump to our clusters, to Tetrate Service Bridge. So I'm first going to log in as an admin to give you a global view, if I could type correctly, of what a view of all the tenants, all the workspaces might look in this environment. So if I take a look at this, you see, what is this? Maybe 24 tenants. So 24 groups of app teams that have access to this. And because I logged in as an admin, I can see every tenant here, the Bulb Tetrate tenant, the Acme tenant, the ABZ, which is my initials, Tetrate tenant. And subsequently, all these tenants then further subdivide each of the environments into workspaces. So I have a demo app that I can apply policy to my demo app. I have the book info application deployed here. It's carved up into a workspace. So we're going to focus within our demo on this Folk Tetrate workspace. So I have a little script that simply adds a unique word before all these objects. So Folk happens to be the one selected. So since I'm logged in as an admin, I can see everything, but I'm going to actually log out. And let me put on the hat of now a developer who owns the Folk application portfolio, or the set of microservices that fall into that tenant. So I'm now going to log in via an OIDC, OAuth flow. This is going to send me to Keycloak, which is my identity provider in this demo environment. And I'm going to log in as my user Folk into TSB. And when I do so, now I'm going to just have a contextualized view of just the Folk application, the Folk tenant in this case. So all I can see is mine. I don't see the other 24 tenants. And likewise with the workspaces, I only have access to my own. Now this is, a pretty simple example that I'm logging in as admin, but I very easily could also author policy if I was an administrator. I should have shown you that before I logged out here. I could author policy for my workspace within Folk. Let's say for my secure application, I want to give security admins some sort of, let's say, security admin role, and my test users, let's say they're just going to be readers, so they're read only. So I can apply those changes, and now when those users log in, it's going to be contextualized, and they're only going to have access to manipulate and control the global mesh based on these policies that are derived from their users. So I'm going to go back to my Folk user, which will just give me the view of what I want to see here. Cool. So this is basically a way to slice up what we could describe as a multi-tenant environment that has multiple clusters, maybe multiple namespaces that are being used for the logical isolation within Kubernetes. We can slice and dice that up also using that same construct at the mesh level. So let's jump forward and actually do something a little bit more technical. So this is a replay of that slide of, I talked to you before. I talked about its responsibility for pushing down configuration, managing routes, managing security policy, lifecycle management, all that sort of stuff. So that's what the job of TSB, or what our global management plane is, for every single workload cluster or local control plane that's under its control. Now, what does that actually mean in practice? Well, it's supposed to deliver the contextualized and proper config that is formed correctly for each local cluster. Now, you might say that seems easy. Like, I don't get why that's a big deal. So let me walk you through kind of an interesting scenario. So we already talked through this notion of workspaces or applications. So let's pretend workspace 1 is app 1, workspace 2 is app 2. We've made some Istio, some service mesh configurations. Now these applications are going to start to talk with each other and consume each other's services. So first, imagine if you're the developer or the person operating, or you're just simply the app 2 user, and you need to talk to app 1, which is this green one in workspace 1. What might that Istio config look like for global service discovery? Well, it's probably going to be configured to say, well, if I want to talk to app 1, I should favor cluster 1. And if cluster 1 isn't available, I can fail over and load balance between cluster 3 and 4. Simply because this is east and west, so we want to keep it local. Likewise, if I happen to be running in cluster 1 here, this upper left one, and I'm app 2, my service discovery, my routing, my load balancing also looks a little bit different. So it's going to look different from if I'm in cluster 2, because now I have a local copy of app 1. So my routes, the way my service entries, the way the mesh should be configured should be, well, you should favor the guy that might be running on the actual physical node right next to you. He's in your same cluster, and if that fails, fail over. And so you see with this different topology, every config that's delivered to these localized clusters is going to look slightly different. And as the topology of our applications change, as new clusters on board, that's going to be ever changing. And so you essentially need a overarching system that knows how to deliver that config and knows when the topology changes. So that's really the job of the management plane. So what specifically is it going to monitor? What is it specifically going to deliver? Well, it's going to understand the topology and understand how to make MTLS connections. So global mesh connections using Istio across clusters that are distributed, potentially even in different clouds. It's also going to know how to set security rules and security policy based on where your applications live. So imagine, though my domains don't indicate it here, imagine app one is in the public cloud and app two is in the private cloud. Using that knowledge of where they're running and our trust domain and the fact that they are maybe public and private, we can author policy and have the management plane distribute that policy that takes that into account. And then lastly, it'll propagate the routing information, the optimal path information for how to reach the most optimal version of a service and failover when necessary. So let's actually get into that in some significant depth. So I have a pretty simple application deployed into my Folk workspace here. If I go back to what this looks like, it's actually a back end and a front end that simply know how to call each other, and it's spread across a secure cluster and an insecure cluster. And when I start to invoke the services, you'll actually be able to tell by the names where we're running. But Cloud West is secure, Cloud East is insecure. So this is what that service looks like. The front end to it, again, that's simply a front end that's going to know how to talk to a back end. So we can see from the UI, this is my Cloud East cluster. I'm running in a specific namespace. Istio injection is enabled. And so I should be able to start to make calls across the mesh to discover my backend. So I do have a version of the backend running in this environment, or rather in the same namespace. So I can simply use the Istio service and we'll know how to route that. We'll know how to do service discovery there. So if I submit that, calls my backend, you see this lovely picture of a cat doing work for me. He's a contractor. I don't pay him very good, but he's cute. And it tells us I'm running on the Cloud East cluster. So this is basically, the most simplistic example. That's actually not just demoing anything that happens within the global service mesh. But what happens if I actually wanted to expose my backend for discovery globally in a global service registry? Well, within my configuration within TSB, I actually have, let's find my insecure application. I have what's called, a gateway deployed. I have a definition of my front end you see here. And then I've said, I actually want to expose my backend over a global mesh endpoint. So this insecure.folk.public.mesh isn't going to be resolvable for my browser. It's only something that Istio and the global mesh knows how to resolve. So if I place this now, I get the same application, but now I've addressed it in a different way. And I actually didn't just imply that this was Kubernetes services and this is using something that's in the same namespace. So let's talk about how that actually happened. If you think about what I talked about before, this management plane is going to be distributing service entries or route information on how to consume, how to connect to all these services. So if I take a look at my East cluster, and if I get my service entries, I'm simply first going to grep on the word folk. We'll pick up that there is insecure folk public.mesh. That's what I just called. So let's actually take a look at what this guy looks like. That's been distributed by the global management plane. And we'll look at the YAML of that. Oops, I forgot a letter. So what this is telling us, you'll notice it says, hey, if you're trying to route to insecure.folk.public.mesh, well, in this case, you have a local gateway you can address, and it's a 10.00x overlay Kubernetes overlay IP address. So I know that that's just Kubernetes routing, and my service always will resolve there. Now I have a very similar service deployed in my West cluster that's insecure. So if I do that same request, you notice now I change insecure to secure. I'm traversing now clusters because this is coming from my Cloud East cluster, talking to my backend that's in my Cloud West. So how did that happen? Like, why did that work for us? Well, if we go back to all the service entries that our management plane distributed, we can ask it, well, what information do you know about our secure endpoint? So let's let's execute the same command, but ask what you know here. So for secure folk public.mesh, it's going to now say, oh, you're going to have to actually remote route remotely. You're going to have to talk to a remote gateway. Here's the endpoint, but you can tunnel over the MTLS endpoint of 15443 and connect to my service. And if we go to the TSB UI, we should actually be able to see this topology take place. If I select my right clusters and give this guy a refresh, we notice we can see my traffic traversing from my insecure cluster, which is here in GKE East, going to my Cloud West cluster, which is secure. Now you might be saying, well, that's not a good thing, right? I don't want insecure to go to secure. That's somewhat problematic given the names that you're saying this is traversing, and how you're modeling your applications. And you'd be right. This is where that tenancy and our workspace and the ability to apply policy comes in. So if I wanted to lock that down, we have the ability to apply default settings that are going to be applied to any of our services that are part of our secure zone. So in this case, it's actually 4 different clusters. The one we're dealing with here are all the services that run in the Cloud West. So I can say for any service running, I'm going to set my MTLS policy. So this is going to be the peer authentication. I'm going to require that. I'm going to make sure that that's strict. And then also I can set authorization policy. So right now I had it custom. I was enabling anyone to connect to me. But by selecting workspace, now this means only applications that are part of this workspace of Folk Secure app can make a connection. And so if we think about what that means, well, that's only going to be the front end or the back end or any pods that are part of the mesh that are in the DMZ, Private East, Private West, or Public Cloud West secure namespace. So if I talked long enough, hopefully my policy has been propagated out. Now I get an RBAC access denied. So the mesh just gave me a 403, said, hey, you can't make this communication. So if we look a little bit deeper into what happened, I can change to my Public West cluster now. And let me make sure I'm in the right namespace. Folk demo secure. We'll actually see what policy was just blasted out to any cluster that's associated with this workspace. And that's going to be an authorization policy. Looks like I have it in my command history. Let me show you what's listed here first. So you notice when I made that change in the management plane, this default east-west policy was actually updated because I already had a policy that said allow everything, but it was just updated when I made that change to what you see above here. So it sent out an Istio authorization policy. You don't need to know what namespaces are part of the workspace. It automatically will look at that. And as those namespaces or new namespaces are added, it will continually update this policy. Now, if I go back to now, let's say the Cloud West endpoint, which is part of the secure cluster. Now this should work for me. So let me make sure he's running. And do I have it in my history? Yeah, here we go. So let's make sure that secure can talk to secure. Yep, and I still give my lovely cat picture. And so this is all because of these policies, these service entries, and the global configuration that was pushed out. Now, if I happen to have this backend running in a couple different clusters, given the fact that we also know locality, so we're going to plumb the global mesh with locale-aware routing that will favor, in this case, if I'm in US West 1, it's going to keep stuff in US West 1 unless there's failures. As I mentioned, we're going to put a couple links in the notes of this to some other demos that actually demonstrate with like book info how we're able to fail across or keep traffic local and only fail across locale boundaries when there is an issue, and also something that's interesting with potentially our legacy VMs. So that's the main thing I wanted to show you all. Again, if we kind of wrap up with what are the challenges that that's trying to solve, was trying to help us span trust across multiple environments, understand the global topology of that mesh, and as that topology evolves and new clusters are identified, we want that security policy and that trust to always follow along. We want it to be also intelligent in how it manages traffic. And more importantly, we want to have a very targeted enablement of people that have specific responsibilities, should only be able to see a specific portion of the mesh or their applications, give that multi-tenancy aspect to allow them to do their job and not affect others. So with that, I'll pause there. Hopefully that was beneficial, and maybe Peter or Ryan, if you guys have been monitoring the chat, or if there's any questions that y'all have from what I showed, let's discuss it. What came up?
Yeah, this was awesome. The demo and everything. Like, as you were going and explaining the things, I was going through stuff. I was thinking, oh, what's the analogy, right? Like, why? Like, one thing that came to my mind is, okay, so I own a car. I have a single car. I take care of it. I put gas in it, right? I clean it, et cetera, et cetera. But then, let's assume we scale that out, right? Let's say I get 2 cars. All right, I can still manage it. 3, maybe I'll need some help. But then once you get to like 50, 100, well, once you have a fleet of these cars or clusters, if you wish, or applications, you need something. You need like a higher level, some higher level pane of glass that I can look through, right? And I can commandeer things and configure that. Like, I basically need a management plane, right? Is that a right, like, at a high level, is that like a good analogy in a way, or is there any other analogy that you guys been using?
No, that is right. I don't have a long list of analogies. As you started to talk about that, actually, my mind went to like having a wagon and then saying, oh, I need to bolt an engine onto it. Oh, I need to bolt a gas tank onto it now. And oh, now I need a transmission. When you just started with like a radio flyer wagon, when then at the end of the day, you're like, holy smokes, I just built a car. Like, I didn't know I needed a car, but that's what I built. And that's what I see organizations do, enterprises do. So if you look at this picture, this probably is what eventually evolves with maybe different names. So the things I showed you typically start to get embodied within like CI/CD toolings, and enterprises start to almost build their own management plane using different technologies. And then all of a sudden, 18 months down the road, they're like, holy smokes, what did we build? And the answer is, well, you kind of built an enterprise platform that looks like this, except for it's probably really fragile. It costs you millions of dollars. You have dozens of people that know how to build and run it, when that's not really your core business. So I think that's the punchline of give some thought to what you're building, and don't start from scratch every time, because we fundamentally believe that eventually all enterprises, as they scale service mesh, are going to need an architecture that looks somewhat like this. Whether you use different tools or different bespoke pieces that maybe are slightly more fragile and difficult to manage, eventually at some time you're going to look back and say, oh my God, I just built the car that I didn't even know I needed the car in the first place.
I mean, you are in the end trying to solve your problems, right? And then you go and start, as you said, start building things. Oh, let me add this, let me add that. Oh, now that we added this, that uncovered like a slew of other things that we also have to take care of. And soon enough, you, like, as you said, you've built your own management plane. You spend a lot of money.
That like four people know how to use, and when they quit, you're screwed.
Yeah, that is the truth.
Yeah, and the other thing that I really liked is the idea of me as an admin, or your DevOps team, or your security team can actually go in and say, no, these are some of the policies that we want to apply across the board. Only we want to be able to control it, right? And we delegate some of those things back to the app teams and say, by the way, you can change all of these things, but everything else, no, it's us, right? Which is, if I'm thinking, I can't, like, none of the Istio resources come to my mind, but there are, it's actually destination rule, right? Some of the, like, you can change a lot of things there, you can break a lot of things, right? when the only thing that I need to change is that subsets, for example, right? But I can also
Yep.
go and change MTLS if I want, right?
Yeah, that's exactly what we see. And so I didn't go into, for time and for complexity, I didn't go into it in depth, but we're really trying to break kind of those personas and those constructs that you see in the Istio CRs into 3 different buckets. And I'll start, and then we call them groups. So we're grouping functionality together. So security groups is pretty self-explanatory. That's going to be anything security related. Gateway groups I would describe as more like your ingress and your north-south load balancing. So how do you expose things external? That might not be app devs that are like most concerned with like exposing themselves as a load balancer. That might be more the platform team or DevOps people. And then lastly, traffic is just that. How do I manage traffic? How do I manage the client side load balancing? How would I do a canary with my specific application? And so what we see in practice is most organizations using RBAC and using, the things I demonstrated for you, those that, use this system that have a security role get read access, or rather write access, and can set policy here. Those that are responsible for load balancing and network infrastructure typically are configuring gateways, configuring ingress, and kind of the north-south traffic into the clusters. And lastly, app devs, want to configure things like, how do I do canaries? How do I do an A/B test, or use those subsets like you mentioned? And so they get the access to control the traffic groups. And it isolates it very nicely that those personas can just target the things they care about.
That's yeah.
And one of
Go ahead.
the things that makes that I was thinking about in terms of like RBAC is that it seems like there's this mediation between that Tetrate Service Bridge mediates the details of implementing access to clusters of various flavors in a way that's consistent across. Maybe you have something in AWS, maybe you have something in GCP, and like you don't have to get all of that perfectly right. You just get it right in TSB. And can you maybe explain how like the RBAC roles and the users kind of get, like how that works in terms of like mediating between your company or enterprise directory and how it maps onto the various types of clusters that you might be operating?
Yeah, so I think there's a lot in what you asked there. I think the most simplest answer is Tetrate Service Bridge does not replace any of like the RBAC or the identity infrastructure that you have. I think you said it, but I want to reiterate it. We plug into that. And then the fact that I've logged in as Adam Zwicky, or in this case, Folk, I'm going to derive a bunch of roles and groups that are associated with my identity that's coming from an enterprise directory. What then you can do is map that to, so which workspaces, which tenants, which portions of the service mesh does that person own? And you actually don't have to worry about the infrastructure at all, because your platform team, or those that actually manage the global service mesh, they will have already mapped via these selectors, well, which infrastructure does this configuration apply to? So it gives you a central control point where you're really applying configuration once to the management plane, and then it's sending out to the correct clusters where you don't have to manage RBAC or access control of the individual developers to do applies of config to those local clusters. It's all handled by the MP, the management plane that we have.
And it seems like you're also, you don't have to worry too much about handing over like more privileges than you wanted to specific, because like you're actually like, if somebody gets offboarded, it shows up pretty much right away that those people no longer have permission to make updates to your production clusters or whatever. And whereas if you had handed out like a more broad privileges to a particular application team, say, you'd have to deal with that separately. I don't know. Does that make sense? Like,
yeah, it does. I think I would say it another way, in that the Kubernetes security policy and how you manage service accounts and the policy associated with those accounts and the users that can do what to what namespaces. Um, if you extend that to slicing up Istio, gets very, very complex quickly, and then you're going to multiply that by the number of clusters you have. This greatly compacts that. And then, as you said, as soon as someone's offboarded, as soon as they're no longer part of your identity provider, they're not going to be able to log in and change policy, make any changes. And secondly, you're also able to see an audit log of who did what. So in this case, you can see during the demo, 14 minutes ago, this is a GUID, but this was my user. It should say folk here. Like I made a change to security to change to mode 3, which is the configuration change. So you have that trail of then also what changed what changed where, and how that was pushed out.
That's awesome. Like I'm still thinking about the like.
I'll think of a better analogy for you.
No,
Peter.
but
I should have had a good
no,
one.
no, no. But one thing that came to mind as you were talking and everything is like it's almost like I did a lot of like Istio workshops and all of those things, and I'm always talking about how networking concerns, right, were moved out of the applications into the sidecar envoy, right, and let the network people deal with that configuration. Let me worry about the application myself, right? And this seems like a similar paradigm shift, right, where you go, why would I have to care about all these things if this can be pushed up or down, right? Like pushed up in a way, but delegate only the things that I'm concerned about back down to me, so I don't have to necessarily write all the configuration and worry about those things. Let the security people worry about security. I don't want to touch that, right? I don't want to break something, right? They're the experts, not me, right?
Yeah, you're absolutely right. So I have one customer that likes to call this their global guardrails. So developers just inherit this as global, as guardrails. It's making sure they don't go off the road and do something incorrect. Because make no bones about it. Like this is complex stuff, and it is easy to make a wrong decision or make a wrong setting. So we talked a little bit about authentication and authorization, but we could very well say like we want to set global policy for retries and timeouts and circuit breakers, or global policy for what egress you always have to go to, or this is for shaping how you want failures to happen across your cloud zones. Being able to set that at a global policy where your developers don't have to spend, one ounce of muscle memory or brain cycles, one brain cycle on that. That's a pretty powerful construct because it's just by far safer, right? Making it impossible to do the wrong thing is a powerful construct.
Yeah. And it also has implications on compliance and audit, right? Like it can be challenging just to find out what the current state of things are, and with if you have a global view and policy, it seems like you do away with a lot of the ambiguity in some sense.
Oh yeah, absolutely. I mean, PCI comes to mind immediately. The surviving a PCI audit is all about being able to prove that your compensating controls are in place. Well, if you can say, hey, it's impossible for someone to misconfigure this or to break this control, that audit is going to be dirt simple then for you. You'll pass it simply, very, very easily. And as a plug, I mean, we do have a guide for setting up PCI environments with service mesh and how TSP makes it really easy.
Awesome.
Yeah.
I mean, I could talk without him for another hour, but Peter, what do you think? How are we on time?
Yeah, I mean, if you have any more questions, maybe just one more question, Orion, if you have anything top of your mind, or if...
So I don't think I can narrow it down. Maybe we'll do a part 2.
Yeah.
Part 2 is great. There's lots of stuff. Like I said, the demo gods were against me today, so I have a little extra gray hair when nothing was working 2 hours ago. So let's do a follow up, and I can show even more cool stuff that I had planned to do today.
Yeah,
that'd be great.
That's awesome. Thanks again, Adam.
Yep. Great talking to y'all.
Thanks, Adam.
All right, Orion.
So awesome. Thank you, Adam, for putting together this presentation. We hope you all found it useful. and of course Peter for being the. I think of Peter as the producer of this show, so he's and the director both. So he does, as always, great work. And we hope you'll join us in 2 weeks for the next episode of Istio Weekly. You can find the schedule as well as past episodes on istioweekly.com. And we always put the tutorial material up on GitHub at github.io/tetraitelabs.io/istioweekly. And you can always chat with us on the Get Istio channel in the Istio Slack workspace, slack.istio.io, or leave a comment on this video.
All right. Thanks, everyone. See you in 2 weeks.